gauge factor is considered as one of the important specification of the strain gauge. So in short, the final form is gauge factor, which is defined by del R by R divided by del L by L, which is equal to 1 plus 2 mu, where mu is the Poisson's ratio. And the type of transducer is the hot wire meter. Regarding the hot wire instrument, hot wire meter, there is already another video. You can watch that video for the hot wire instrument. Other type of sensor or transducer that is used for the measurement of temperature is resistance thermometer. We know that the metals, they are positive temperature coefficient. Metal has positive temperature coefficient. It means RT is equal to R0 into 1 plus alpha 0 into T. So where RT is the resistance at T degree centigrade, R0 is the reference, the resistance at the reference temperature, alpha 0 is the constant. So if you expand this equation, R0 plus R0 into alpha 0 into T. So what you can see that this indicated the starting the reference number, which is R0, and as the temperature increases, you can see that the resistance also increases. So this particular concept that can be used for the measurement of temperature. So change in temperature is going to appear in the form of change in resistance. So these type of sensors or the transducers are called the resistance thermometers. Another type of transducer is thermistor. Thermistor is nothing but a thermal resistor, but it is based on the semiconductors. As we discussed before, the transducer, which is the thermometer sensors, where if you use the metals are involved, actually metal has got a positive coefficient, temperature coefficient, whereas the semiconductors has got negative temperature coefficient, which means that as the temperature increases, the resistance drops. Now these type of devices are very sensitive because not unlike in the case of metals the change is going to take place with time, whereas in the case of semiconductors they are very sensitive because the conductivity of a semiconductors are has got more influence by the temperature. So that's why these type of sensors are very common in terms of many circuits, and there are some relations that we are supposed to understand, that is given by the equation RT1 is equal to RT2 into beta into 1 divided by T1 minus 1 divided by T2. So in this particular equation, RT1, RT2 are the temperature at T1 and T2, resistance at T1 and T2 temperatures respectively. Resistance T1, T2, resistance at temperatures T1 and T2 in degree Kelvin, because it is absolute temperature. Beta is a constant, and of course T1 and T2 the corresponding temperatures. So this type of instrument has got a transducers has got value of resistance ranging from 0.5 ohm until about 0.75 mega ohm. This much high value of resistance, wide range of resistance resistance values are associated with this type of sensors, which are called the thermistors. And one of the other limitation of this type of the thermistors are their relationship with respect to temperature is not linear. So it's not going to be a linear scale. So that's why very limited range of application that can be used, because if you look at the graph, it is the response is like a non-linear graph. So this is supposed to be the temperature, and this is supposed to be the resistance. So since the graph is really like a non-linear graph, so we can consider only a very short part of the graph. I mean, it's very short duration where the graph is almost linear. So that's why an application will be restricted to very specific temperatures. And another advantage is that these are very cheaper because the very inexpensive components, and plus the connections wise, also there is no complex circuitry is required for this type of sensors. The size is very small and is commonly available in the market. Next type of transducer is the photoconductive cell. It's also a variable resistor whose value of resistance is based on or depends on the amount of light incident to it. So this device also working in the negative region, I mean the negative relationship with respect to light. More the light, then less will be the resistance and vice versa. So more amount of light is going to the light is incident to the device, I mean to the LDR, definitely the resistance, more light means less resistance. So this is the inverse relationship. So this is again very similar to what we call the thermistor, but in the case of thermistor that is working with temperature, whereas the photoconductive cell is working with light dependent resistor. So these are the main types of resistive type of transducers, which is very common in practical applications. Another important type of transducer that is used for temperature measurement is called thermocouple. In the case of thermocouple, from the name indicate, thermo means temperature, couple means two. So there are two dissimilar wires, they are connecting together. So we have got an iron wire connected with another material constant ion, and this has got two junctions here. This junction is normally called as a hot junction, whereas one junction which is kept at a fixed reference, which is called the cold junction. So if there is a temperature difference is there, that different temperature difference normally we call as a delta theta. If there is a temperature difference is existing here, that will give rise to a voltage which is called the E, and this E is equal to A into delta theta plus B into delta theta square. Delta theta is the difference in the temperature, and V are the some constant which is dependent upon the type of the material that is used. So in this particular case, there must be a circulating current in the loop, and hence you will get some reading across the moving coil instrument. So this is also one of the common sensors that can be used for very high temperature applications. For example, you can go up to maybe 1400 degrees centigrade measurements of temperature in the case of the furnace and other the aluminum smelting units. In similar applications, you can use this type of sensors. Main issues with the type of sensors is the low output, that is one of the case, and also the non-linearity. Non-linearity is one of the serious issue, and the second issue is what the low output, because we don't get the adequate output voltage from this particular type of sensor. Another smart sensor that can be used for temperature measurement is the IC sensor or the integrated circuit sensor, and the commonly used such integrated or the IC sensor or the transducer is LM35, and which is a very simple device, and this device has got three terminals. One is input, ground, and the output. So this particular IC based on the semiconductors IC will give direct output in the form of with a sensitivity of 10 millivolt per every degree centigrade. So every degree centigrade will give you 10 millivolt. For example, if you have 100 degree, if you want to measure the 100 degree, then this is going to be like 1000 millivolt, which is supposed to be 1 volt. Okay, so this type of circuits are used for low temperature applications. Suppose in order to measure the temperature inside some equipment or machinery, for example computers and other type of systems where the temperature that is to be monitored, it's not very high temperature, it can be used for temperature maybe within 100 degrees centigrade. So this type of sensors are also very common in smart devices. Now this slide is talking about the comparison between different type of the thermal transducers. So first let us look at what are the advantages of each of these type. So let us start with thermocouple. They are self-powered because of the difference in the potential. I mean the difference in the temperature, there is a potential to be created, which means that it is self-powered. Very simple in construction, and which is rugged. They are inexpensive because there is no complex circuitry there, so it's very inexpensive. Wide varieties are available because depending upon the type of the material they use. In our example, we have considered the iron and constant iron. So there are many other combinations of material that can be used for various applications. And of course, it can be used for wide temperature range. Now, talking about RTD or the metallic type of detectors, is we have seen the thermometers, resistance thermometers, transducer. They are more stable because they are mostly they're using the metal as the main element. They are more accurate, more linear. Graph is more linear as compared to what we call thermocouple. Now, talking about semiconductors based the thermal sensors, which is the thermistor, the output is really high. The response is much faster, as we had already discussed, and connections are easy. But of course, there are some limitations that we are going to discuss in the next slide. And talking about IC sensors, LM35, they are most linear, high output, and it's very expensive. Okay, and also it's very easily can be connected to digital circuits. Now we are also looking at the various disadvantages of the type of sensors. The first sensor, thermocouple, they are non-linear. Already we discussed in the previous slides. We already discussed about the non-linear relation of the thermocouple. Low output because the output, the amplitude of the output or the magnitude of output normally will be very limited. Reference is required, because we need to have a reference point. So we need some additional circuitry for maintaining this reference voltage. Reference temperature, and they are less stable because if there is a difference in the temperature, definitely there must be some change in the output. Talking about RTD, which is the resistive temperature detector, they are normally expensive. Self-heating issue is there because once it is heat, because it's an accumulation process, it will heat by itself. And of course, for the operations of an RTD, we need a current source. A current source is required because normally RTD is a passive transducer. So in order to transfer this into voltage or then it needs a current source. Because of thermistor, nonlinear relationship, limited temperature range, it cannot be used because of the nonlinear nature of the graph. Bias required. It needs some external power source, so the bias is required. Self-heating is also another issue associated with thermistor. IC sensors, power required or the bias required. Self-heating is an issue, and IC sensors are used for very limited applications. So in this particular lecture, we have mainly discussed about what are sensors or what are transducers. I just want to highlight one more point that sensors and transducers, sometimes they are interchangeable words. So probably you can use sensors and sensors or the transducers name. Okay, almost having the same meaning. The sensors normally, these type of sensors are the devices which are capable of transforming a signal from physical source to electrical only, whereas the transducers are they are capable of transforming energy from one state to another state, from physical state to electrical or any other form. So in generally speaking, they are almost doing the same job. Okay. So in this lecture already we have covered the transducers. We defined the transducers. Then also we have discussed about how they are classified depending upon the transduction process. Then we have discussed today about different type of thermal transducers. So in the next class, we are going to focus on other type of transducers, like capacitive transducers, inductive transducers, and their different applications. Thank you for watching this video. Hope you have benefited from this particular video. Thank you, and we'll meet again with another topic. Thank you so much.